All right, guys, here's our fourth quarter exam review. It's just the first video. As you can see, I'm not going to fit everything on this one. I'll try to probably cram these all together, though. But anyway, here we go. Number one, they're asking you to write these. Each degree measures in terms of radians. So you just have to obviously know what formula to use on these. So anyway, if you're going to take this first angle and convert it to radians, you just have to remember we are multiplying by pi over 180. And again, the way I usually remember this, when you write it in terms of radians, usually has that pi in it. So the pi is going to need to be in the numerator for that to occur. So in this case, the pi is in the numerator. So you can start canceling here. I can cancel out a factor of 10. So I have 27 pi over 18. I can continue to cancel. I know 9 goes into both of these, so this is just going to equal, if you divide the top and bottom by 9, you get 27 divided by 9 is 3, so 3 pi on top and 2 on bottom. So this one is 9 pi over 2, which makes sense because 270 degrees is on the unit circle, so you should kind of see that anyway. Number 2, asking you to, again, still convert. So I'm going to multiply this again by pi over 180. And again, to just simplify again, just to save you some time, you can divide 108 divided by 180 and simplify. It ends up being 3/5. So these cancel, you get 3 and 5. Don't forget that negative that's right there. So this will be negative 3 pi over 5. And that is number 2 converted into radians. Do it one more time with the 144. So this is going to be pi over 180 once again. And again, 144 divided by 180, just saving time here for the sake of the video, that's 0.8. So we're going to get 4/5. So these cancel, you get 4 and 5 when you cancel these, and you end up with 4 pi over 5. So again, all we're doing is multiplying by pi over 180. So moving on to the other conversions, we're going to convert these to degrees. So we're just going to flip that equation when we do that. So instead of multiplying by pi over 180, in this case, we multiply by 180 over pi. An easy way to remember this is, in this case, when we go to degrees, these pi should cancel. We normally don't have pi in our degrees. So here they cancel, and we don't have pi in our degrees. So here we just need to multiply. I know 180 divided by 3 is 60. So because 18 divided by 3 is 6, so we're just kind of using that same idea. But anyway, I'm still going to multiply this all out. So it looks like I just have 7 is the only thing left over here, 60 the only thing left over there. So 7 times 60 is 420 degrees. So number 4 is 420. Next up, we're going to multiply, again, instead of pi over 180, 180 over pi. We multiply these. So 180 divided by pi. And again, the pi's are going to cancel. At least they better. Next up, 180 divided by 9. I know that's going to simplify, and then I'm going to multiply those numbers out. So this is, just so you know what I'm doing here, I'm going -8. By the way, this is going to be 20, because 18 divided by 9 is 2. So that cancels. I'm just going -8 times 20. So that's going to be -160. And that's negative 160 degrees, again, remember that. So that's going to be number 5. And then lastly, number 6, I'll just keep this in case I need it. So I'm going to multiply yet again by 180 over pi. Obviously, we need to know that formula, or we're going to be in trouble when we get to these. So next, I have 180 divided by 12. If I did that right, I would be good. So these cancel, and that gives you 15. The pi's cancel, and it gives you 1, so there's really nothing there. So the only thing left to multiply here is 7 times 15, and that's going to give you 105 degrees. So that is converting to degrees and radians to degrees. Next up, number 7 through 10 are asking you to sketch a triangle, and then once you sketch it, find sine, cosine, tangent, all those ratios and all that good stuff. So we need to draw some triangles here. So anyway, the first one, we have the point 9, 12. So I'm going to go ahead and sketch that triangle. So I'm going to have my XY plane here. I'm going to 9, 12. Looks good to me. and I'm going to draw a little triangle. So this triangle again is 9, that's 12, and we're going to do a little Pythagorean theorem here, which is 9 squared plus 12 squared equals r squared. So I'm going to solve for my radius, so that's 81 plus 144. So r is the square root of 225. So we're going to need to simplify that square root to put into our hypotenuse. So I know 225, divide that by 25, you're going to get 9. So actually it's a perfect square. So the square root of 225 is just going to be 15. So that comes out nice. And we have a nice Pythagorean triple. I guess I could have noticed that if I was paying attention. But anyway, we have our side. So if you want to find sine of theta or alpha, I think they're using alpha here, but we can use theta. It's no big deal. We've been using that. Alpha is just another Greek letter, represents an angle. And this is our angle right here. Again, you can call it alpha. I'm using theta. So I'll just say they're the same. It'll just a variable. Okay. So sine of that angle is going to be opposite over hypotenuse, so 12 over 15. And you just want to simplify that. So these both are divisible by 3, so that's going to be 4/5. So if you want to do the reciprocal while we're at it, that would be cosecant. So that's just going to be 5/4. And then we just kind of move down the line here. So we have cosine theta. Well, that's going to be adjacent over hypotenuse, so 9/15. Which again simplifies because you can divide the top and bottom by 3. So that would be 3/5. And then we're going to do secant of theta, which is 5/3. Next up, we have tangent of theta, and that's going to be opposite over adjacent, so 12 over 9. So 12 divided by 9, which is 4/3. And finally, cotangent of theta, that's going to be 3/4. So those are going to be your 6 trig ratios based off of that point. Next up, another point, we're going -3, +1. So I'm going to come over here and plot that point. So if I go left 3, up 1, that looks good to me. Set up your triangle. And again, my triangle in this case, that's a -3, that's a +1. So I need to find my hypotenuse. So I'm going to go -3 squared plus 1 squared equals r squared. So this would be 9 plus 1, so 10 equals r squared. So r is the square root of 10. And again, you can't simplify that one, so I'm just going to leave it as it is. And now we need to find our ratios. So I'm going to go ahead and set all these up real quick. And we're going to, again, calling this theta, why not? You can call it whatever you want here. But again, it's always at the vertex. So I got sine, I got cosine, and then I got tangent. So let's find those first, and then we'll flip them. So sine is going to be opposite over hypotenuse, so that's 1 over the square root of 10. You need to rationalize this. Don't forget to simplify it. So I'm going to multiply the top and bottom by the square root of 10. So you get square root of 10 over 10. So that's going to be sine of theta. Cosine of theta is adjacent over hypotenuse, so that's a -3 over the square root of 10. And here, rationalize yet again. Multiply the top and bottom by that radical. So I have -3 radical 10 over 10. So that's going to be cosine. Finally, we have tangent, which is opposite over adjacent, so that's going to be -1/3. Again, I just put that negative on top because it looks better that way. But as long as you have the negative somewhere, you're okay. All right, reciprocals. We have cosecant of theta. I got to keep this tight here, but here's the deal on this. We had this ratio right here. I want to flip that one. And the reason why, if I flip this one, I'm going to put that radical on the bottom, and then I'm going to have to rationalize it. I don't want to do that. If I can just flip this original, I would just have the square root of 10 over 1, or the square root of 10. I'd rather do that. Same thing here. I'd rather take this original cosine value and flip it for secant. So secant of theta is going to be -radical 10 over 3. I'm going to keep that one because I don't have to rationalize. And finally, cotangent. I don't have to worry about that because -1/3 I didn't have to rationalize anyway. So this would just be -3 or -3 over 1. So those are going to be your trig ratios for number 8. And then next up we have number 9. We have 2 negatives. So here I'm going to go left 8 and down 6. So left 8, down 6, that looks good to me. Set up your triangle. Again, left 8, down 6. Now this one, if you know it's a 6, 8, 10 triangle, great. If not, Pythagorean theorem again, and that'll get you there. So this one I'm going to have, again, sine, I'm going to have cosine, and I'm going to have tangent. And we're just going to do SOHCAHTOA. So sine is going to be opposite over hypotenuse, so that's negative 6 over 10. That's, again, using this angle. So simplify that, you get negative 3/5. So that is sine. Cosine's adjacent. Here's my angle. This side's adjacent to it. So I have adjacent over hypotenuse, so negative 8 over 10, which is negative 4/5. And lastly, we have tangent, which is opposite over adjacent, so negative 6 over negative 8, which is positive 3/4. So those are going to be your 3 trig functions, now your reciprocals. And as you do these, I'm just going to use this space because I don't want to cram too much here. So the reciprocal of sine, that's going to be cosecant. So that's going to be negative 5/3. Then I have secant. Flip this one, so that's negative 5/4. And cotangent of theta is flipping 3/4, so that's going to be 4/3. So those are your 6 trig functions for number 9. And then we get to number 10. Now number 10 is a little different, if you haven't noticed. It's different because of the point. You know, it's just negative 4, 0. So here's what we're going to do with this. Obviously, we're going to plot it real quick. So here is negative 4, 0. Now, what we can't do is we can't draw a triangle. But what we do know is this terminal side, we do know the angle associated with it. That's going to be 180 degrees. So what I'm going to do is I'm going to take another point that lies on that side that we can do something with. And this point is negative 1, 0. Notice it's on the same line. It's on the same terminal side of the exact same angle. And when we pick a point that's on the unit circle, I know that is cosine of that angle, because this is the angle, and I know my y value is the sine of that angle. If I know sine and cosine, I can then find tangent, and if you have sine, cosine, and tangent, you can find all the reciprocal identities. So that I know at this point, I know sine of theta, because I use this point instead of the negative 4, I know sine is 0. I know cosine of theta, I know that one is negative 1. And then I know that tangent of theta, well, that's opposite, or not opposite, well, it is opposite over adjacent, but I don't have a triangle, but it's sine over cosine, so it's 0 over negative 1, or 0. So those are my trig functions. Now, and again, that's just, I'm not using a triangle here, and you say, well, why am I not using a triangle? It's like, I can't draw one. I mean, it's flat. There's no height. So I have no triangle to draw. I have to use the unit circle concepts for this. So anyway, once you have all this, now we can do cosecant. Now, this is 0 over 1. So you have to put something there so you have a fraction, because I got to flip it here. And so this is going to be 1 over 0. Well, if it's 1 over 0, this is going to be undefined. So you just say undefined. I don't have much room to write it, so I'm just going to put UND there. Same thing here with secant. Well, not the same thing with secant. Secant, this is negative 1 over 1. So if you flip negative 1 over 1, you get negative 1 over 1, or 1 over negative 1. So this is going to be negative 1. And tangent, now that's the one that's like sine, because see how it's a 0 on top at the beginning? When you flip it, 0 is going to be on bottom. So cotangent of theta, that's going to be an undefined value yet again. So anytime you have a point that lies on the x or y axis, what you're going to want to do, since you can't draw a triangle, is just use the unit circle. So just kind of bring that point down to 0, 1, or negative 1, 0, or whatever the case may be, and use that point instead. So that's what I did for number 10. So last one for this video, it's the first question, it says part 2, it doesn't really matter here. But we are going to be, I'm just trying to figure out what color to use. Looks like blue, I'm going to use blue. So we are just evaluating, finding exact values of these trig functions. So here we go. Number 1, first thing I want to do is I want to find a coterminal angle so I can not use the 495 degrees. So to find a coterminal angle, you just go 495 minus 360. So this is going to be 135 degrees. So I'm going to find the secant of 135 as opposed to the secant of 495. Even though they're the same answer, this is easier to find. I know that this is in the second quadrant. I know exactly where it is, so I'm going to go ahead and kind of sketch that point. Remember, sketch the point. It's negative radical 2 over 2, positive radical 2 over 2. That's the point, the terminal point for that angle. Now secant, that's 1 over cosine. So what we're going to do is we're going to take this and we're going to flip it. We're going to flip that number because that's going to give me the secant value. It's the reciprocal of cosine, which is the x. So this is equal to negative 2 over radical 2. I'm flipping that x value. Now you got to rationalize this, so I'm going to do that. So this is radical 2 on top, radical 2 on bottom. So I get negative 2 radical 2 divided by 2. The 2's cancel, and you get the negative square root of 2, and that's your answer for number 1. So again, you have to know the points, or you could have to be able to set up the special right triangles as you solve these. Number 2, I'm going to take negative 210 degrees. Now you have to be aware when you do these is that you're going clockwise. You're not going counterclockwise. So I know I'm going to be starting here, going counterclockwise. And again, once you get to 180, we're going to go 30 more degrees. So that puts me here at this point. And again, think of the triangles, since I mentioned the triangle here a second ago. This point, since I'm kind of where I'm at because I just barely went up here on the unit circle, but the triangle I'm using is that 3069. Is I'm going left a lot, up a little. So it's negative radical 3 over 2, positive 1/2. So again, I use that reference angle because I know that I'm 30 degrees above 180. So I know that's a 30-60-90 triangle that kind of goes in there. So now that I know that, sine is my y value. So, and again, you can also look at it as opposite over hypotenuse. Well, that's 1, and that's 1/2, but it's also just the y value. So anyway, long story short, sine is the y, which is 1/2, and there's nothing to do there because it's good to go. So that's going to be number 2. Just have to know to go clockwise. Number 3, we have sine of 9 pi over 4. And here, notice it's just all sines and seeing if you know the unit circle at this point. Again, I'm going to do coterminal angles yet again. Now with this one, if you don't know what I'm going to do with it, I'm going to go 9 pi over 4. And I'm going to subtract 2 pi because this one's too big. 8 pi over 4 is 2 pi. So I'm going to take away an 8 pi over 4. If you do that, you end up with 1 pi over 4. So I'm finding the sine of pi over 4. So I can do that. Remember, we're in the first quadrant here. And again, we're at this point right here in the middle, which is radical 2 over 2, radical 2 over 2. So sine is your y value. So my y value is, well, they're both the same, but my y value is radical 2 over 2. So that's going to be number 3. And lastly, number 4, I don't need to do a coterminal angle on this. I just have to know to go clockwise again. So I'm going to take this, and let's see, if I'm going 4 pi over 3, that's going to put me in the third quadrant. If you can see it here, I'm going to go a little farther than that. That's going to be in the second quadrant. But anyway, I'm going to go here. That's 180 degrees. That's 3 pi over 3. I'm going to go 1 more pi over 3. That's like my reference angle. So I'm going pi over 3 or 60 degrees farther. So that's going to put me right there, kind of. You can set up a little triangle. I had to make it smaller because I kind of screwed up there. But this point, I'm going to move it down here. You need to know this point, but I'm going left a little. I'm going up a lot. So left a little is negative 1/2. Up a lot is radical 3 over 2. That's the point you need to find. Once you have that point, sine is the y value. So sine is nothing more than just writing radical 3 over 2. So that is number 4 on your review. All right, next up we have number 5. This one's asking, or these sets of problems are asking you to find the angle. So we're looking for an angle. So this is really good if you know your special right triangles. So this first one, we're in the first quadrant. So I'm going to go ahead and sketch this. And again, we're going right 1 and then up radical 3. So this is going to look something like this. So if you go up 1, or right 1, up radical 3, and if you know your special right triangle, I'm going to go ahead and sketch that special right triangle real quick. And again, it is, this is 60 degrees right here. It's a 30, 60, 90 triangle. So that's 30. This is x, x radical 3, and 2x. So if you kind of look at it, you can see that that's my x value. That's my x radical 3. So that angle right here, that is going to be 60 degrees. So that's 60 degrees. That's your angle for number 5. That's all you're doing. You have to know those special right triangles. So know that one, and know your 45, 45, 90 as well if the sides are equal. So that's what's happening here. So on this one, we're going right and down. So in this case, I'm in the 4th quadrant. So I'm going, draw my triangle right here. And again, we're going right 5, down 5. I don't know why I almost tried to write a radical there. So the special right triangle in this case is going to be a 45, 45, 90. So that's 45. That's really tiny, probably hard to see, but those are 45 and 45. And that would be x, x, x square roots of 2. I don't need the hypotenuse here. I just need these 2 points. So this is 45 degrees right here, but we're going down 45 degrees. We're going clockwise. So I'm going to say this angle is negative 45 degrees. And we can use that as our answer. Also note, you can go around the entire unit circle. That's, it depends on if that's what you need to do or not. So you just go 360 minus 45, so 315 degrees. That could be an answer as well. It depends on what the multiple choice answers show you. So that's going to be number 6. And they are asking you to put these in radians and degrees. I just want to double check that. So this one again would just be pi over 3 radians. And this one, I'll just do this one. That's negative pi over 4. Actually, I can do both. It's no big deal. That's 7 pi over 4. So those are going to be your radians because the answers can be in radians or degrees. Next up, we have number 7. Looks like we're going left and down. So here I'm going to go left, negative 2 radical 3, down 2. I'm going to draw my triangle here. And again, if you know, that's negative 2 radical 3, negative 2, that's your x value. And that's your x radical 3 value. So again, you're using this triangle right here. The x radical 3 is next to the 30-degree angle. So that's my 30-degree angle right here. So my angle at this point, if I did my degrees, that'd be 180 plus 30 using my reference angle. So that's going to be 210 degrees. Or you could do your radian angles, and that would be 3 pi over 3 is at 180 right here. And this is going to be one more, actually it's 6 pi over 6. We're doing 30-degree angles, sorry. So 6 pi over 6 would be here. I'm going down one more 30-degree angle, so that would be 7 pi over 6. So that is number 7. And number 8, this one's pretty quick. I don't need to really do a lot of explaining, I hope, at this point. You're going up 45 degrees. So it's a 45, 45, 90. So this is just 45 degrees. You can also say that that is pi over 4 radians. So that is your angle in radians and degrees. So that's number 8. All right, moving on. 9 and 10 say sketch each given angle. Sketch each given angle and give its reference angle in degrees and a positive and negative coterminal angle. So we're going to be really focusing in at this point on reference angles. So here, if you're going down 50 degrees, that's probably not to scale, but really that is the reference angle is negative 50 degrees because we always measure to the closest x-axis, and well, that's where it is. So there's your reference angle. Now your coterminals, you have negative 50 plus 360, so that's going to be 310 degrees. So that's one coterminal angle. They want a negative one as well, so I can also go negative 50 minus 360. So that's going to be negative 410. So those are your coterminal angles. Just add or subtract 360 from that. But the reference angle, again, you're going down 50. It's the angle from your x-axis. You're good. Next up, we have 405 degrees. What I would probably do first on this one is find the coterminal before I do the reference. So I'm going to go 405 minus 360. So I can figure out what that angle is. So at this point, if you subtract that, so that's 45 degrees. So that's a coterminal angle. Now they said they want a positive and a negative coterminal angle. Well, this one's still positive. So I'm going to subtract 360 one more time. Might as well, because that's going to give me a negative angle, and I want a negative angle. So that's going to be negative 315. I should know that already, though. So those are your coterminal angles. You have 45 and negative 315. Your reference, again, it's just the angle from your x-axis. Well, we're on the positive x-axis here, so that's just going to be, in this case, you're at 45 degrees, so that's your reference angle. It's 45 degrees because that's the measure from your x-axis. So that is coterminal and reference angles. So that's it for that. Number 11 says, do that without converting to degrees. So we're going to go ahead and find these reference angles and things like that, coterminal angles in radian form. So no cheating. We have to do it in degrees. So no big deal. We could do that. So negative 3 pi over 5. First off, again, you want to figure out where you're at. So here I would know that I am in this fourth quadrant because, again, I'm going in a clockwise direction. And I know if as I go clockwise, 2.5 or 1/2 pi over 2 is right here. That's 1/2 pi. This is more than that. So I'm over here somewhere. Okay, so my reference angle is going to be this guy. It's how much do I have left? Well, 5 pi over 5 is going to be pi. So if I've gone 3, I need to go 2 more. So my reference angle is going to be, in this case, 2 pi over 5. So that is your reference angle, and you're just going to find the measure of that angle. And again, you can go either way. I guess I did that over here without looking. When you're doing the angle, you can just do a positive. So I can probably come back there and call that a positive as well. It's just a positive angle. It's the measure, you know, as you're going through that. It just depends on your perspective and how you're looking at it. If you want to keep that a negative, that's fine. But here, it doesn't matter. As long as it's just the angle in that case. You know, I can be doing that angle going this way if I wanted, or going that way if I wanted. So that's why that positive negative doesn't really matter. So either one would be fine. Now here they want the coterminal. So to find those, we're going to take negative 3 pi over 5. And I'm going to add 2 pi. But 2 pi says I'm thinking, what number can I divide by 5 and get 2? So I don't have to get a common denominator. I mean, this would give me a common denominator, I guess, but I'm going to add 10 pi over 5 because that's 2 pi. So negative 3 plus 10 is 7 pi over 5. So that is a coterminal angle. They want a positive and a negative, so I'm going to also subtract. So I'm going to go negative 3 pi over 5 minus 10 pi over 5. So that's going to be negative 13 pi over 5. So there is a positive and a negative coterminal angle. And then number 12, we're going to do the same thing with that. Now notice here, 13 pi over 6 is more than one revolution around the unit circle. So I'm going to start here with my coterminal angles, since I might as well help me do my reference angle a little bit better. So I'm going to go 13 pi over 6 minus 12 pi over 6, because that is 2 pi. I'm subtracting 2 pi. So that's going to give me a coterminal angle of pi over 6. Now I want to get a negative coterminal angle, so I'm going to keep subtracting. I'm going to go pi over 6 minus 12 pi over 6 again. And that gives me negative 11 pi over 6. So that represents 2 of my coterminal angles. Now a reference angle, right here, found it. Let's measure from the x-axis up to that angle, so that would be pi over 6. I'm good. So there's your reference angle. Again, just the measure from the x-axis up to your terminal side. That could be a positive or a negative x-axis. Here is the positive axis, so we're kind of good. All right, these next set of problems, we're going to need a calculator for them, just so you're aware. Number 13, just have your calculator handy. But here we are trying to solve for x, solve the missing side of a triangle. So this is, here we're going to see, well, what trig ratio has the opposite side and the hypotenuse in it? Opposite and hypotenuse, yeah, that's going to be sine. So this is going to be sine of 43 degrees, and that ratio is equal to opposite over hypotenuse. And this is a little review of some stuff that you did in geometry, because this is geometry. I'm going to solve for x. I'm going to multiply both sides by 22. So those cancel, and you plug this into your calculator. So when you do this on your calculator, I just want to make sure on your calculator you hit the mode button. And when you go to your mode button, this is if you're using the TIs, the third option down should say radian degree. Well, here we are in degrees. You want to make sure that your calculator is in degrees, or all the answers you're going to get here are going to be wrong. So make sure that is in degrees. So I'm in degrees, and I'm going to go 22 times the sine of 43 degrees, not radians. See, that would calculator screw that up if it thought it was a radian angle. So this case, we're going to get x is approximately 15.004. And that's your missing side for number 13. Do this again. We're looking at number 14 now, and I got an opposite side, and I got an adjacent side. None of these are hypotenuses. So this is going to be tangent, that's opposite and adjacent. So I'm going to go tangent of 38 degrees, and that's opposite, which is 20 over x. So here I'm going to solve this for x, and with the way you do that, you can think of this like a proportion if you'd like, if that makes it any easier. You're multiplying both sides by x, or you can think of it as a cross product. I don't care, but you're going to end up with x tangent 38 degrees. If I'm doing this like a proportion, that's going to equal that cross product. So that's going to equal 20. And to solve for x, we're going to divide by tangent of 38 degrees. So that is going to need to get plugged into your calculator. Again, make sure your calculator's in degree mode, not radian mode. So 20 divided by tangent of 38 degrees. X is approximately 25.599. And that is number 14. So keep it going here. We have one more, and this is a tricky one. Oh no, we got to find an angle. So I'm going to go ahead and call that angle, I'll call it theta. Let's call it theta. So theta, it's an angle, right? So let's first look at the ratio that you're given. The ratio that you're given, I have an opposite side, and I got an adjacent side. So we are looking at tangent, but the unknown value is not one of the sides, it's the angle itself. So it's going to be tangent of theta is equal to 18 over 27. I know 18 over 27 simplifies, and if you want to simplify it, go right ahead. Call it 2 divided by 3. So we have tangent of theta equals 2/3. Now the question is, what the heck do we do now? Well, again, a little review of geometry for you. What we do is we do the inverse operation. Normally an inverse operation is that, hey, if you're multiplying, let's divide. That's an inverse operation. Or if you're adding and you want to subtract, that's an inverse operation. But what if you have to do the inverse operation of a function? Because this is a function. Well, you want to do the inverse operation of a function, you evaluate it. Well, what do you evaluate it at? You evaluate it at its inverse trig function, which is tangent inverse. So if you evaluate the function at its inverse function, then those two functions will cancel out and give you theta. Well, if you do that to one side, you're going to have to do it to the other side as well. So we're going to go tangent inverse of 2/3. So that is what you're going to need to plug into your calculator. If you do that, you're going to get your angle. As long as you're in degree mode, you're going to get your angle. So you're going to go tangent inverse of 2/3 or 18 over 27, either one is fine. And that's going to give you approximately 33.69 degrees. So there we go. That's number 15. And that's just in time for us to get to our trig graphs. So here we go. On our trig graphs, number 16, this is a nasty looking guy because of that period. But let's just kind of go through the list here before we start graphing it. First off, the amplitude is 3. Now the period is always 2 pi over b. Now in this case, b is pi. Now you may think this makes things way worse. It's actually the exact opposite. It makes it way easier. I don't have to worry about pi's because they're going to cancel. Your period is just going to be 2. That's actually a good thing. We don't have to worry about pi. It's really great. Now the phase shift, I don't have a phase shift, so I'll say none. Vertical shift, none. Interval, yep, we have an interval. Remember, we're going to go the period times 1/4. Again, I don't have to worry about pi's here. 2 over 4 is 1/2. So, with that being said, I can now go and graph this. Here's how you're going to do it. Start with your x-axis, and we'll label our x-axis real quick. Again, this graph has no phase shift, so I can just go ahead and draw my y-axis. Now, when you do that, your interval is just 1/2. You don't have to worry about pi's. So my first point would be 1/2. My next point would be 1, and then 3/2, and 2. That's all it is. Just don't write the pi's. It's not so bad. Now your amplitude is 3. So I'm going to go up 3 and down 3 because there's no vertical shift. So when you're graphing cosine, be aware cosine starts at the top. Got to know your parent graph in order to do this. So I'm going to start at the top, then I'm going to go to the middle, then I'm going to go to the bottom, back to the middle, and back to the top. So your graph, make sure you got the curve there. We can see that curve. It's going to look something like this. So that is your cosine graph, number 16. Keep it going. One more, and then we're all set. So here we got 4 sine of x minus 3 pi over 2. So this one has an amplitude of 4. Period is 2 pi. It's 2 pi over 1. So you don't say none. There's a period. Phase shift, yeah, we have a phase shift. So that's going to be right 3 pi over 2. So we have that phase shift in there. Vertical shift, I don't have any numbers out here, so that's none. We always have an interval though. Even though we're not asking for it specifically in the exam, we need it. So this is going to be, our interval is going to be, in this case, 2 pi times 1/4. So that's going to be pi over 2. So this graph, start with your x-axis. So my first point, again, I always start the this 3 pi over 2. So I'm going to start here in the middle. I'll call that point 3 pi over 2. And I want to go left because I want to find my y-axis. So if I go backwards, that's going to put me at 2 pi over 2. So pi, then pi over 2, and then go back pi over 2 again, and that puts me right here at 0. So that is my y-axis. So I found my y-axis. I could go back one more. I'm going to go to the right though. So I'm going to go pi over 2, or 3 pi over 2, which is where I'm currently at, plus pi over 2, which is my interval. So that's 4 pi over 2, or 2 pi. So that will give me a full period. So here I go, I'm ready, well, I'm not ready to graph it, sorry. I still have my amplitude I got to put in here. So let's go up 4, and let's go down 4. So that's my top, and that's my bottom. So again, we start at 3 pi over 2. This is a sine graph, so it means I start in the middle. So the middle here is 0, right here at 3 pi over 2. From there, I know sine goes up, so my next point will be up at 4. And again, for here, I went backwards. So you see I'm heading down as I go to the left. So my next point is going to be at -4. My next point will be back in the middle at 0. And my next point will be here at 4. Now again, and when we graph this, you're going to notice when I do my curve, this looks an awful lot like a cosine graph. Well, it's not. Be aware, I started here. This is where I began my graph. So I did start at 0. Just when you look at the way everything got shifted over, it looks like cosine if I was starting here on my y-axis, but I wasn't. I was starting here. So don't let that confuse you. This is a cosine graph. If I went out a couple more points, that would be 5 pi over 2, and this would be 3 pi. I mean, I can keep going. If you just look at it from this point going forward, you would notice, you know, it does look like a sine curve if you just don't draw the rest of it. If I just start here, you see that's a sine graph. So anyway, that is sine. That's number 17. Those are your trig graphs. All right, guys, moving on to number 19. 19 and 20 are graphing First off, a reciprocal function, and second, a rational function. Now, a reciprocal function are the ones we use our transformations on. So that's what we're going to do here. We're going to use our transformations. We're going to recognize with this -4, we are going to be going right 4, and hopefully you recognize this +2 means we're going up 2. So in order for this to work, you need to know the parent graph for your reciprocal function, which is this guy, where you have a vertical asymptote at your y-axis and a horizontal asymptote at your x-axis. So I'm going to take that graph, I'm going to move it right 4 and up 2. So I'm going to take this xy axis, this graph, here I go. I'm going to start with my vertical asymptote. So I'm going to take this, I'm going to go right 1, 2, 3, 4. So I'm going to go 1, 2, 3, and 4. So luckily I got room here so I can go out farther. And I'm going to draw that vertical asymptote. Next I'm going to go up 2. So I'm going to take my horizontal asymptote, which was at 0, and go up 1, 2. I'm going to draw my horizontal asymptote right here. So I know this graph, if you look at it, is going to have this same shape to it. So we're just going to go ahead and sketch that curve. It's going to go top right and bottom left. So here, not really asking for too much, so we're just going to go ahead and find those values right there and try to darken that in a little bit for you. And that is your graph for number 19, just a quick sketch. So that's again 19. So next step we have number 20. So this one, before we go and find all this stuff, and there's a bunch of questions it's asking, it's basically asking for this, so I'm just going to go ahead and find it like this. But we have to be able to factor it. So I'm going to take this and factor. So let's do it. All right. So 3x squared, if you're looking at these, you know, you have to multiply 3x times x. That's going to give you 3x squared. And then if I have 2 and 1, either way is going to get you 5, but you got to pay attention to the signs. They got to both be positive. So I'm going to go 2 and 1, because 2 plus 3 is going to give me 5, and those are going to all give me positives, and that's important here. On the bottom, we have x and x, that gives me x squared, and I want 3 plus 1 to give me 4. Again, the signs are all positive. So I'm going to go 3 and 1 plus plus. Now one thing you will notice, these cancel. So if you look down here at your holes, you're going to have a hole. I'll go ahead and find that first. I'm going to take that x plus 1, set it equal to 0. Your hole is at -1. It's that canceled factor. But we want the point where that hole occurs. So to find that point, notice this simplified version of my function. I'm going to plug -1 into that. So y is equal to 3 times -1 plus 2 divided by -1 plus 3. So -3 plus 2 is -1. -1 plus 3 is +2. So -1/2 is your y value for your hole. So I have a -1, -1/2. I have a point on my graph. It's a hole, but you know my graph goes towards it, jumps over it. So that's just as good as having a point on my graph. So there I go, I have that. Next, let's go down the list here. The x-intercept. We need to take our numerator, which is now just 3x plus 2. Notice this is gone. So I'm taking 3x plus 2, set that equal to 0. So that's going to give me x equals -2/3. So my x-intercept is at -2/3. Next up, my y-intercept, I'm going to plug in 0 for x. So if you plug in 0, these guys go away, and you're left with 2 divided by 3, because that's 0 plus 2, 0 plus 3. I'm plugging in 0 for my y-intercept. So that's going to be +2/3. So now I have my y-intercept. My vertical asymptote, I'm going to set my denominator equal to 0. My denominator is now x plus 3. So set that equal to 0. And you get x equals -3. So there is your vertical asymptote. And lastly, your horizontal asymptote, you look at the degree of the numerator and denominator. In this case, they are equal. They're both to the first, and to the first. So what we do in this case is we take the leading coefficients, which are 3 and 1, and we divide them. So this is y equals 3 divided by 1, or better yet, just call it y equals 3. So there's obviously a lot of little details. This is some of the oldest stuff we did this quarter. We were kind of wrapping up with rationals as we started fourth quarter. So these are some things you may need to review. This kind of gives you a heads up of some of those concepts, but it's not everything. So anyway, I'm going to go ahead and take all this information and let's graph it as best we can with the space that I have. Hopefully it fits. We'll see. I mean, it's going to have to. I have no other choice. But let's go. X-intercept is -2/3. So my biggest point looks like just 3, so I should be okay. I'm just trying to scale this out a little bit. So I'm going to go -2/3. I have a point right there at -2/3. I have a y-intercept at +2/3. So there's my y-intercept. I have a vertical asymptote at -3. So I'm going to put a vertical asymptote right here. And I might be running tight with space here, but I'll make it work. The horizontal asymptote's at +3. So I got a horizontal asymptote right there. Actually, it looks like oh good, my graph's going to be up there, so that's good. My hole is at -1, -1/2. So -1, -1/2. It's about right there. Okay, this looks perfect. I think I know exactly what's happening. So this graph, I think they're telling you to you need to use a minimum of 6 points. You know, in the end, if you can, you know, that's one thing you can do. I can tell you, if you can see the graph, go ahead and graph it. So what I mean by that is these points are kind of telling you your graph is kind of doing this. It's approaching these asymptotes. So I know to start up here, start curving down, go through these points, jump over the hole, don't go through it, and approach your vertical asymptote. So that is good to go. This graph doesn't have an x-intercept to the left of that vertical asymptote, so by default it has to be up here, because if you drew it down below that horizontal asymptote, it would have to cross over the x-axis. Well, it doesn't. So that has to be your graph for number 20, and all the important information that should answer the questions that this problem is asking you to answer. So with that, I'll keep moving here. We're going to move on to 21. This gets us into all the probability concepts. So with 21, we have a box that contains 2 red marbles, 3 white, and 4 green, and 1 blue. 2 marbles are drawn at random without replacement. So in this case, they say, what's the probability of getting a white marble and then a red marble? So I want a white, then a red. So first off, let's get our desired outcome, our total outcomes. Let's add all these up. So we have, you know, basically our total outcomes are going to be 2 plus 3. Keep going here, plus 4 plus 1. So 5, 9, 10. So that's my total possible outcomes. So I want to select a white marble, and there's 3 whites. So I'm going to have 3 out of 10. That's my probability of getting a white. Now here they're telling me we're not replacing it. So now when I multiply, because when you do multiple probabilities, you multiply those probabilities together, I'm going to have a 9 for my total possible outcomes. So I now want to get a red marble. So there are 2 reds. So I'm going to go and put 2 up there. I'm just multiplying these 2 numbers together. So I'm going to go 3/10 times 2/9. And that multiplies out to give me 1/15. And I'm doing that on the calculator. Or as a decimal, it's 0.06 repeating. Either one is perfectly fine. So that's going to be number 21. Number 22, we have 10 cards. They're numbered 1 through 10. The cards are well shuffled and are drawn at random. So we got 10 total possible outcomes again. So that's kind of convenient, just a different scenario. So 2 cards are drawn with replacement, so I am going to not be dropping that number this time. Find the probability of choosing a prime number in both the first and the second draw. So out of these numbers, we're going to start by listing all the prime numbers from 1 to 10. So as I list these out, the first prime number is 2. 1 is not prime, so we start with 2. We have 3, 5, 7, and that's it. Every other number is divisible by either 1 or itself, or more than just 1 in itself. These 4 numbers, though, are only divisible by 1 and itself. That's why 1 isn't prime, because it's only divisible by 1, which is itself, and it kind of copies twice. By definition, it doesn't represent what a prime number is. So we always start with 2 with our prime numbers. Be aware of that. So we have 10 total numbers, and there's 4 primes. And again, here we are replacing. So we're going to multiply by 4/10 again because we're replacing. So it's the same scenario happening twice. So if I was trying to do this in my head, I know that's 2/5 times 2/5. So that's going to be 4/25. So if I was doing that by hand, I'd get 4/25. As a decimal, that's 0.16. I mean, you have a calculator on the test, but still, you can do it by hand. So that's 22. And 23, a number selected at random from the following set. Find, and then you have to know what this means. So here I'm going to write it out. Probability of prime. We get a prime number given that it is odd. Again, find the probability of a prime number given that that prime number is an odd number. So our desired outcomes are the odd numbers. So in this case, and again, I am on 23, there's 2 different scenarios, so I'll write each one out. But again, the first one, again, find the probability that it's prime given that we're selecting from the odd numbers. So if you look at this set, we have 1, 3, 5, and 7. We have 4 numbers here that are odd. Out of those 4 numbers, we have 3, 5, and 7. We have 3 of them that are prime numbers. So this probability would be 3/4. As a decimal, that's written out as 0.75. So that's what we're doing on that first one. The second one, find the probability that we get an odd number given that the number is greater than 2. So look at your numbers that are greater than 2 and see how many total possible outcomes there are. Greater than 2 is 3, 4, 5, 6, 7, 8. So I have 6 total numbers. Out of those 6 total numbers, how many of them are odd? So I have greater than 2. I have 3, 5, and 7. So I have 3 numbers out of the 6. So 1/2 or 0.5, 50%, that are going to be greater than 2 from that group. So that's all you're doing on 23. Obviously, you have to know how to read that and what it means. 24, keep going here. We have not used blue yet, so let's do it. This one, we have a box contains 3 marbles, 3 blues, 5 reds, 4 whites, and 1 is drawn at random. So the first one says, find the probability that it is blue, given that it is not red. So first thing I got to do is, again, figure out my total possible outcomes. So I want to say all the ones that aren't red, add them up. So blue is not red, so that's 3. And 4 is 4 white, so I have 3 blues, I have 4 whites, so that's 7. And that's going to be 7 for my total possible outcomes. So from that group, what's the probability that they are blue? There are 3 blues, so 3/7. And again, 3/7 divided, 3 divided by 7, 0.429 as a decimal. So that is number 24, the first one at least. And then the next one they're asking about, what's the probability that it's not blue? So not blue, given that it is not white. So just as before, let's get that denominator first. So the condition in this case is that it's not white. So that's every color that's, let's see, every color is not white. So it's not, we're basically excluding the whites. So we're looking at the 3 blues and the 5 reds. So 3 plus 5 is 8. So from that, what's the probability that it's not blue? So we have, in this case again, because we're on 24, I don't want to get the wrong number here. So The ones that I'm looking at are the blues and the reds. So from that group, what's the probability that we don't get a blue, which means we're looking for reds. So there are 5 reds, so we're getting 5 reds out of the 8 that are not white. So 5 divided by 8, oops, 0.625, I should know that. But anyway, that's going to be 0.625 or just 5/8. So that is number 24. All right, next up, 25. So in the Cocoa Beach Air Race, 6 planes are entered and there are no ties. So we have 6 planes, no ties. And how many ways can the first 3 finishers come? So this is one of those counting principle problems. So we're going to be multiplying these options together. So I want to get all the possibilities. So this is just fundamental counting principles here. So we have 6 planes. How many ways can the first 3 finishers come? So the first plane, when we pick a first place finisher, we have 6 planes. So if I want to get all the total possible outcomes, I'm going to multiply by how many options I have for the next plane. Well, there's 5 for the next plane because I already picked one here. So there's 1 less here to choose from because I already have a winner. So there's 5 more planes. Now that I've picked my first 2 out of the 6, I have 4 planes left. So I'm going to multiply this number by 4. So this is going to be 30 times 4, 3 times 4, that's 12. So this is going to be 120 total possible outcomes. So that's going to be number 25. All right, and then now number 26. So in this case, what we have is we have this disc jockey. He can play 4 songs. Now there are 8 to select from, so he's picking 4 out of the 8. So in how many ways can the program for this line segment be arranged? So just to clarify things a little bit here, order is going to matter. We're trying to say like the way the songs that you're playing, like they're being played in different orders. Now again, that can be confusing. Obviously for the exam, we need to make that clear so you're not sitting here trying to guess does order matter or not. So I'm kind of giving you that input here. And if there's anything confusing in the exam, I'll let you know. But here we're going to just see how many ways we can take these songs and make different shows out of it based on what order you do them in. So what you have to realize in this case, order matters. So that makes this a permutation. So this is going to be a permutation. And the formula here, you have P and then we have N and R. So on 26, on 26 we're doing the permutation. So this is going to be n prime, or n factorial, divided by n minus r factorial. So that's going to be the formula we're using. And in this case, n is going to be 8 because we have 8 songs to choose from. So we have 8 divided by 8 minus 4 factorial. These are both factorials on top and bottom. So that's the formula we're using. N is the total number of songs we have to choose from. 4 is how many we're using. So that's my N and my R. So that's 8 and that's 4. So I'm going to go 8 factorial divided by 4 factorial. And again, remember this is 8 times 7 times 6 times 5 times 4 factorial divided by 4 factorial. So again, these are going to cancel, and you're just left with 8 times 7 times 6 times 5. So 8 times 7 times 6 times 5, 1680. That's a lot of ways to rearrange those songs. So maybe that's why radio stations always play what it seems like the same songs, but they're in different orders, so it's a different show. So it's okay, apparently. It's not okay. It's kind of ridiculous. But anyway, that's 26. And then 27, we have a book club offers a choice of 8 books. So they're just saying the 8 books that you can have to choose from. And this is confusing too a little bit. How many ways can a member make a collection? So this is a collection. So in this case, the order is not really going to matter. It's just you got a collection of books. Here's my collection. So it's not any particular order. It doesn't need to be in any particular order. So this one, we're going to say the order doesn't matter. So in this case, it's going to be a combination. And again, it's going to be C, and that's R and N. And again, we just got to plug in the numbers here. This one's going to be R is 40, so it's kind of a big number. and n is the number, or sorry, r is not 40, n is 40, and r is going to be 8. So n is 40, and I said that backwards. That's why I got myself confused. Sorry. So this is 40, and that's 8. So I'm going to have n factorial on top. I should probably write the formula here. I'll put it down below. Times r factorial, which is 8 factorial, times n minus r, so 40 minus 8 factorial. So again, this is n factorial over r factorial, n minus r factorial. So that's the formula I'm using on that one. So I'm just going to plug everything in and simplify it here. So that's 40 factorial divided by 8 factorial, and then 40. I don't know why I'm doing that again. Sorry. I don't want to do that. I already did the 40. Let me just erase that bottom part there. Sorry. So that's going to be 8 factorial times, that's 32 factorial. So when you simplify all this, my numerator, that's 40 times 39 times 38 times 37 times 36 times 35 times 34 times 33 times 32 factorial. That's a big numerator. Okay, so that's divided by 8 factorial times 32 factorial. Again, the whole point of doing all that work there was just to cancel those 32 factorials out, so I can plug that into my calculator. So it's going to be 40 times 39 all the way down. If I do that right and not hurry too much. It's like the last problem, I got to get it done. So I multiply those numbers on top. It's going to be huge. It's like an E number on my calculator. But divide that by 8 factorial, and all our problems will be hopefully solved. So if I do that, if I do it right, I keep messing up, but I'll get it. Don't worry. So if you go 8, and then you can do, remember you got your math and probability buttons that you can use. So I'm just doing that here. But this is going to still give me a lot of different scenarios here. We have 7, 6, 9, 04, 6, 8, 5. Boy, that's a lot of numbers. So that's 76,904,685 different collections. There are 40 books. That is a lot. So that's how many collections you could possibly have. And again, that's a big number. So that is number 27, and that is your exam review. Good luck, and I'll see you guys in class.